Welcome to Lesson 29, Solving Literal Equations for Mrs. Boyle's math class. We're going to start today with a definition for a literal equation, and that is an equation with more than one variable. So very simple, just write that in. An equation with more than one variable. And just as a side note, we're just going to add a little note here that they can be solved for any of the variables in the equation. It doesn't always have to be y or have to be a certain letter. So an example of that would be y equals mx plus b is an equation most of us know, slope-intercept form, but it can also be solved for x. It doesn't have to be y equals. The n didn't turn out there. We could also solve it for x. So what we would want to do is subtract b on both sides. So we would end up with y minus b. And then we would also have to divide by m to get x by itself. So divide by m. And then we would have x equals y minus b over m. So that's just an example there. Alright, moving on to a couple of our example problems. We're going to solve each literal equation for the given variable. So the first one says to solve for y. There's an x and a y in this equation. We're going to solve for y, so I'm going to circle the term that has the y in it because we first want to get that term by itself. So we're going to subtract 2x on both sides. That will cancel, and we'll be left with 3y equals negative 2x plus 10. The reason I'm writing it like that is because we normally put the variable terms first and then the constant variables after that. It's just standard form for algebra. So the next step would be to get y by itself, which would mean to divide by 3 on both sides. And when you are dividing, you have to divide the entire equation on that side of the equal sign by 3. And that means that we have this on the top in parentheses, and we have to distribute this division to all the terms in the numerator. So that means we can rewrite this as y equals negative 2 thirds x, or negative 2x over 3, plus 10 thirds, because we have to divide this term by 3 and divide this term by 3. So this could be written in a few different ways. We can write it y equals negative 2x plus 10 over 3, or y equals negative 2x over 3 plus 10 thirds, or y equals negative 2 thirds x plus 10 thirds. So 3 different ways to write that. The most common way would be this third one here. Okay, moving on to the next equation. We're going to solve for x, and right now it's solved for y, so we're going to have to rearrange some things. We want to get this term by itself, so we're going to get rid of this 5 by doing the inverse operation and adding 5 to each side. So we would have y plus 5 equals negative 3x. And the next step would be to get x by itself by doing inverse operations and dividing by negative 3. So then we would have x equals, now just to point something out here, we have a positive equation in the numerator and a negative in the denominator. So that's going to make this whole equation negative. So we can write negative y plus 5 over 3. Or we can write it as, that's an x, sorry, x equals negative y over 3 minus 5 over 3. So two different ways for that one as well. Moving on to some more examples. We have solving for r this time. So we're going to go back to our instructions or reminders on the first page here. And the first one is to simplify as much as possible, which meaning to distribute. And there's nothing to distribute in this problem. But it also says to combine like terms on the same side. So we're going to go back and we have 3r, 2, and 2s on one side, so no like terms there. We have negative 4s and 4r on the other side, so no like terms there. But now we want to get, for our last step here, before we solve, we want to get all the same variables on the same side of the equal sign. So we want all the r's on one side, and we want all the s's on the other side. Because essentially we want to get all the r's by themselves anyways. So we have 3r and 4r. So I'm going to subtract 3r because it's smaller, and I don't really like to end up with negatives. So I'm going to subtract 3r on both sides, which will give me 2s minus 7 on the left equals negative 4s plus 1r minus 8 on the right. And now, since I want to get r by itself here, I need to get rid of this 4s, so I'll do inverse operations by adding 4s on both sides, which will cancel. I also need to get rid of this minus 8, so I'm going to do the inverse operation and add 8 on both sides. So I have 2s plus 4s is 6s, and negative 7 plus 8 would be positive 1, so plus 1 equals 1r. And we know that 1r is the same thing as just r, so we can rewrite this as r equals 6s plus 1. And that's our final answer. Moving on to the next example, we have a formula this time for temperature and how Celsius and Fahrenheit relate to each other. So it asks us to find the Fahrenheit temperature when the Celsius equals 25 degrees. So if there's two ways we can do this. We can first solve the equation for F because we're looking for the Fahrenheit, or we can plug in the 25 for C first and then solve. So that is the way I am choosing to do it. So we're going to plug in 25 for C because we know that it's 25 degrees Celsius. And we're going to have 25 equals 5/9 times the quantity of F minus 32. Okay, now we could distribute the 5/9, but it might be easier to get rid of it by doing inverse operations. We know that it's 5/9 times this other quantity. So to get rid of that, we would use inverse operations and divide by 5/9, which is the same thing as multiplying by the reciprocal. So we'll multiply by 9/5 on each side. And that will cancel the 5 and the 5 will become 1, and the 9 and the 9 will become 1. So all that will be left is F minus 32. And on the other side, we can cancel the 5, goes into 5 once, and it goes into 25 5 times. And then we have 9 times 5 on the top, which is 45. Okay, now we have a very simple equation. 45 equals F minus 32. So all we need to do is add 32 to each side. And we'll have degrees Fahrenheit equals 45 plus 32, which is 77 degrees. Okay, moving on to a couple of real-world application problems. We have the formula for the area of a rectangle is area equals length times width. If a rectangle's area measures 64 centimeters square and the width measures 16, what is the measure of the length of the rectangle? So we're going to plug in what we know. We know that 64 is the area, and that is equal to the length times the width, and we know that the width is 16, so that would be 16 times L. Now we just need to solve for L. So we'll do inverse operation, divide by 16 centimeters on both sides. That will cancel out, and we'll have L equals 64 divided by 16, which is 4, and one of these centimeters will cancel one of these centimeters, and we'll be left with 1 centimeter left. So the length is 4 centimeters. The last problem, the Chu family is taking a camping trip. They live 176 miles from the campsite. If they travel 55 miles per hour, how long will it take them to reach the campsite? Okay, we're going to start with this one. We have a rate of distance over time, which is miles per hour. What we're looking for is how long it will take, which is time. So that's the question, is time. So we want to solve our equation for time. So what we can do is multiply by t on both sides, and then we would have TR equals D, and then we would divide by R on both sides, so that cancels out, and we would have time equals distance over rate. We know that the distance is 176 miles, so time equals 176 miles over the rate, which is 55 miles per hour, so divided by 55. And 176 divided by 55 is about 3.2, and we know that it's hours because our rate was in miles per hour. So we know that our time is going to be in hours. And that's the final answer there. Thank you for listening, and thank you for taking notes.